This is an old trick that carpenters used to draw an ellipse, but I don't know why a carpenter would actually draw an ellipse, but that's what I'm told. This is an old trick. So imagine you had three nails. Nail A, nail B, and nail C. And you put a string around the three nails. Okay? And you tied the ends of the string together, so it's a loop, but it's a stiff loop. It's not like a rubber band. It's an inextensible string. Now suppose you pulled out one of the pins, like let's say C. You are left with some slack in the string, and you can start to draw an ellipse based on the movement of this slack. So here's a demonstration, and I'm just moving the slack, and you could see that as I approach the string, it has to go through C again and go around, and I have a perfect ellipse. Now that is wonderful, but let's try to be rigorous in the exploration here and turn the grid on and do a logical movement of one of the points. So this happens to be on 20, so let's just move it to 20. Let's just snap it to this corner here. And now we're going to make our trace again here. And let's snap it to the next corner now and just see what happens here. So in other words, this is play, but it's play with rules here. And one of the rules, of course, is that you're always going through C here, as you could see. So let's move this again and keep drawing these over and over again. And a methodical construction here of our ellipses will bring some knowledge of what an ellipse is, but it also creates something quite lovely here. Now let's move the other point here a little bit. Let's move it down there and see what happens. We're still going through C, but now we have a different trace. Let's move that down here. So we'd like you to do this, of course, not on the computer, but we'd like you to do this on a piece of paper in your studio, not with nails, but maybe with push pins, and see how you can create an interesting shape here, or that looks volumetric, looks three-dimensional, but is actually rigorously mathematically defined.